Hello dear viewer, my name is Ernar Sakarbekov and this is my video blog. In the world history there are many great discoveries and I can argue that one of them is this chemical reaction. Nitrogen molecule plus 3 hydrogen molecules react to form 2 ammonia molecules. The industrial implementation of this chemical reaction is called Haber process. The process was named for the great German scientist Fritz Haber, who received Nobel Prize for his discovery in 1918. And let's look at the problem that he solved. The major component of air, nitrogen, can be just used up by plants due to the strong triple bonds in nitrogen molecule which holds these two atoms together, not allowing them to separate and react chemically. Fritz Haber found a way how to use nitrogen from the air and make it reactable for further transition to the ammonia form. According to the scientific journal General Chemistry by Petrucci, Haber process, producing more than 130 million metric tons of ammonia per year, is considered as one of the largest industrial chemical processes in the world. To explain Haber's method, you need to know the term chemical equilibrium. The Haber process is a reversible reaction, which means that produced ammonia can break down again to the nitrogen and hydrogen and vice versa. Chemical equilibrium occurs when the rate of forward reaction is equal to the rate of the reverse reaction. And at equilibrium, it doesn't have to be in the middle. The chemical equilibrium point happens when the concentration of products and reactants do not have tendency to change with time. And so at equilibrium you usually do not know more reactants or more products you got in final stage. And in order to avoid this uncertainty, specific conditions are used in industry to shift the equilibrium toward the ammonia. According to Jan Modak, professor at the Department of Chemical Engineering at Indian Institute of Science, adjustment of reaction conditions are referred to the principles designed by French chemist Henri-Louis Le Chatelier. Using Le Chatelier principles, Fritz Haber found desired conditions. By increasing the temperature and increasing the pressure in closed container with fixed volume, equilibrium will shift towards the products. And here is a connection between system. When you disturb the chemical equilibrium, the whole system will try to recover it. Imagine the situation. In closed container we got molecules of nitrogen, hydrogen and ammonia. When you increase the temperature, it increases the rate of kinetic energy of these particles, thus increasing the rate of collisions between these molecules, which in turn will lead to the formation of more ammonia molecules. And when we increase the pressure in this container, it causes the packaging of these molecules so that they stay closer to each other. And this is not the case of chemical equilibrium, and therefore the whole system will try to recover it by decreasing the number of molecules. And the only way to achieve it is to make molecules of nitrogen and hydrogen react with each other. So at certain point equilibrium recovers and the whole reaction stops. Haber process starts in closed container called compressor, and all reagents are in gaseous form. In next stage, reagents float to the container with catalyst in form of iron. Catalyst is a substance that increases the rate of chemical reaction and left unchanged by the reaction. Iron increases the rate of forward reaction. In this container, temperature is increased to 400 Celsius degrees and pressure is increased to 250 atmospheres, and these conditions will lead to the shifting of the equilibrium toward the ammonia. In final stage, mixture of gases go to the condenser, where ammonia is condensed and removed in liquid form. At any such cycle, the yield of ammonia is 15%. Consequently, some unreacted nitrogen and hydrogen left. And in order to increase the yield of ammonia, these unreacted gases go to the recycling process. By recycling, the overall production yield of ammonia reaches 97%. Nowadays, ammonia is used in many purposes such as fertilizer, fermentation, cleaner, antimicrobial agent for food products. But the major purpose is fertilization of soil by ammonia and its salts. When applied to soil, it provides increased yields of crops such as maize and wheat. As Anne Marie Helman-Steen, PhD at chemistry, suggests, fertilizer generated from ammonia produced by the Haber process is responsible for sustaining 1/3 of the Earth's population.